What is up, science coders out there, and welcome back to another Scratch tutorial, and 2023 is right around the corner. It's crazy because my channel is about 3.5 years old now, and we're already close to 300 subscribers, so thanks everyone. But nonetheless, in this video we're going to be learning how to make an efficient platformer script, which I guess you could consider as a sequel to my original platformer tutorial, link in the description down below. But anyway, here we're going to improve upon that original with concepts such as code organization, ordering our game loops, and flexibility of code. So without further ado, let's code. Okay, so the way that this tutorial is going to work is we're going to build everything from the ground up, and then at the end of the video make a little comparison to the original and then this new project. So let's get started. Alright, so the first thing that we need to do is make all of our sprites for this game. Like I said, I'm starting from the ground up. So what we're going to do is go into the costumes after we made a sprite, and then make a square. I prefer it to be like perfectly within any of the grid squares. Doesn't matter the size, but you have to like make sure it's like perfectly snug with all the grid squares. It just makes everything easier to deal with hitboxes in the future. And just rename the sprite to player. Then the next thing we're going to do is just duplicate the sprite, call it level, and then a neat trick you can do to drag a square from both sides is you can press Alt on your keyboard and then just drag from one of the sides and it'll go to both ends. Now let's create some variables. Define a variable called Vx. Vx stands for velocity x, and then Vy. So as you can see, we got those two variables. And then the next thing we're going to do is make a WhenGoClicked and set those two Vx and Vy to 0. That's how we're going to start. And what we're going to do now is say a forever loop and then make a new function or a custom block. And we're going to call this one movement. Yep, movement. Make sure we press run with that screen refresh on here. And now we have this new custom block function. And over here, we're going to define it. What we're going to do is we're going to get an if statement. And then we're going to say if the key up arrow is pressed, then here we're going to set the Vy to a positive value like 15. And then here we're going to change the Vx by, this is a cool script I like to use for left and right movement. That's what these are. These are Boolean blocks. You can put like Boolean blocks. You put them in operators and they actually return a numeric value. So this right arrow, if it's pressed, it'll return 1 or true. And if this left arrow is pressed, it'll turn 1 for true. So if the right arrow is pressed and the left arrow is pressed, it'll do 1 true minus true, or 1 minus 1, which is 0, and then multiplies that value by 5, which is our speed that we want to go at. So 5 times 0 is 0. So this is not going to move when it presses the right and left. However, if we press only the right, it's going to say true minus false, which is 1 minus 0, which would return 1, times 5 is positive 5. However, if the left arrow is pressed, it would return false minus true, 0 minus 1, negative 1, times 5 is negative 5. So we're going to put that in there and then connect the movement to the variable. So as you can see, that's what we got right there. Now this should work, and it does. However, the player moves way too fast. So let's slow down, add a little bit of resistance. So what we need to do is set the Vx to Vx times smoothing factor. Let's try 0.75. That should work. And as you can see, we have nice friction. However, we implement jumping code, and it does not work. That's because we need to connect our movement with the Y. And as you can see, the jumping is really not that natural. That's because we didn't implement gravity yet. So what we need to do is say change Vy by -1. And as you can see, we can jump and fall and move left and right. However, it can phase right through the ground, and that's what we're going to work on next. What we need to do is split off the movement and the collisions. And for now, we're just going to do that in one custom block. However, later on, we're going to be learning how to efficiently split up our code and make it readable. But for now, we are just going to split off all of this stuff. And the next thing that we're going to do is make collision code. So we're actually going to put this back in there because it's pretty important for collision, on the y-axis at least. And then what we're going to do is check if it's touching level. Do an if check, and if it's touching level, then this is a pretty common platformer script. We basically want it to go down, and then when it's detected that it's touched, we want it to go up in 1 increments until it's not touching anymore. So that is a repeat until it's not touching the ground, it's not touching the level, and then we're going to change y by +1. Now that should work. Let's just implement the movement jumping back in. As you can see, that works. We have a pretty nice collision system now. However, as you can see, we can jump in air. And that's because there's nothing stopping us from jumping in air. Now, a quick way we could solve this is by putting this if check inside the touching level. So now we can only jump when we're touching the level. But that's frustrating for many people playing games, right? Because if they're on the edge of a platform and they want to jump off, but technically the player isn't touching the level, they fall straight down, then it's going to be really frustrating. So what we need to do is implement what's called a coyote jump. And for this, we need to create a new variable called in-air and create it for the sprite only. And then this in-air variable is constantly going to be changed up by 1. So it's always like in the air, but the moment that we touch the level, we set in-air to 0. Now let's see. Here in the up arrow check, we need to put a nested if then statement in here, and then say if the in air is less than a certain value, if it's between 0 and 5. So if it's just in the air, but not too much, then we'll allow them to jump. Believe it or not, that does actually make a really big difference. And I'm just going to change the gravity amount so it doesn't feel as much floating. And as you can see, that works. We can pop the XY movement back in there, X movement back in there. And then as you can see, we have a functioning game for downwards collisions. Now, keyword I said downwards collisions because watch what happens when I go on a ceiling collision. Now, as you can see, it goes straight up straight up through the wall. And then when I try to go back down, it instantly zips down there. One of the questions is very easy to solve. The reason why it zips back down is because we never reset its y velocity. So what we need to do after that is set the y vel to 0, and that should work now. So as you can see, we now have constant velocity. Now, to solve the other problem of it going up to get out of the ceiling, we have to put in another if check saying that if the player is going upwards and it touches the platform, we want to go back down. However, when it's going down, we have to go back up. And only when it's going down do we want it to register it's touched the ground, as in the in air is set only to 0 when it's going down. So what we need to say here is an if-else statement, and say if the Vy is greater than 0, what we need to do is put this in the else, also put this statement in the else, put a change y by here, and change y by -5. And another thing that we need to do, check change Vy by -5. For some reason, if you just put a change y by, sometimes it can get a bit glitchy and it won't detect if it's hit a ceiling. So you have to manually change the velocity for it to go back down, and maybe give it a bit of a boost by changing the regular Y position. Now this should work, and we should have ceiling collision. And as you can see, we cannot jump that high. Let's see, this should be very painfully obvious. As you can see, we can no longer go through ceilings, and that is excellent. Now let's get the collision on the x-axis. But before we do that, I want to share with you something that most coders, like most professional coders, will really like. And that is to split your code and make it easily readable. So what we need to do is basically determine, as a better programmer, are there specific pieces of code, chunks of code, that do different functions? And if there are, you might consider splitting them off in their own custom blocks. Like this one handles collision and this one handles movement. So what you could do is just put this in the movement and this one in a new custom block called collision. Also make this run screen without refresh. And then put the collision first and the movement next, because that was the order we put them in the ones. Then nothing should change that much here. And as you can see, nothing that much changes. But now let's move on to X collision. X collision is going to be pretty much identical in that we're going to be checking if it's touching the level, except here we're going to say Vx, and then here we're going to just change the X by -1. We don't need to change the X vel. For some reason that's only an issue with the Y. And then just remove these two, because we're not going to be setting the because it's neither on horizontal collisions. But yeah, this should work for X collision. And I forgot one thing, you actually have to put the change X by Vx in here, and let's see if this works. Y collision works all the same, and then now X collision works like a treat. Now, as you can see, everything works as a treat here. Let's actually lower the friction of the player. So yeah, that looks pretty neat. Let's actually decrease the speed. Let's go into our next topic of organization, and that is separation. We first separated custom blocks, and now we're going to separate the functions within custom blocks so that we know which type of collision we are, whether we are a Y collision or an X collision. For that, we're going to edit this custom block and put a / put direction and call this dir. And basically what this is going to take in is either a Y or an X. And based on that, it's going to do either the Y or X collision. So what we need to do is make another if-else statement. Make an if-else statement, say if dir is equal to Y, then do this script, else do the X collision script. So what we're saying is if we pass in a Y letter, it's going to only do the Y collision. And if we pass in whatever other X letter, then it's going to do X collision. The cool thing is that we can also do that with movement. We can say movement and then add a label, add an input for direction, dir. However, here it's going to be the jumping code is going to be if the dir is equal to Y, and the regular movement code is going to be for the dir of X. And then here we're going to say movement of direction Y and then movement of direction X. Or we could put the collisions and movements in one place just to make it a bit easier for us. So that should work. And as you can see, that works perfectly. We have some nice platformer movement and some nice code organization as well. There's another topic I'm going to discuss. This is crucial for readability and flexibility, editability. So what we're going to do is create what's called toggle variable. In this case, a toggle variable is going to be for the key controls for the right arrow and left arrow. And what we're going to do is replace this key right arrow minus left arrow with the key X variable, just so that we have more organization. So in the else, we're going to say set key X to right arrow minus left arrow, so that this is always going to be either a 1, a 0, or a -1. And then we can multiply 3 times that key X value. Actually, we might want to not hard code these values as well. So make 2 new variables, call them move speed and then friction. These ones can be for all sprites because we also want people to edit these to their liking. So I'm just going to change this to be for all sprites. So what we're going to do here is just replace the 3 with move speed and replace the 0.75 with friction. And here in the original script, we're going to set friction and set move speed to move speeds to 3 and frictions to 0.75, just like we had before. Remember, this is all just code organization. And as you can see, nothing much should change. Then the next thing we're going to do for organization is make a new list called key controls. And then here we're just going to say right arrow, add a new item, call it right arrow. Call this one D to correspond with the WASD keys. Left arrow, then on the 4th item A, then on the 5th item up arrow, and then on the 6th item W. So now we have a list containing all the WASD and arrow keys. The reason I made this list was to toggle between 2 modes of controls without having to change every single key press block. So what we're going to do is create a new variable called key mode, again for all sprites, and initially set this to 1, but make this a slider and change the slider's range to 1 to 2. If you have 3 combinations of keys, you could do 1 to 3. However many combinations you have of keys you might want in your game, you'd want to change it to that. Now, how is this key mode going to help us? Well, basically, if the key mode is 1, then that means the item key mode is item 1, so right arrow. So what we can say here is say the item key mode of key controls. If that's 1, then that'll be right arrow. If that's 2, then that'll be D. Then for the left arrow, we need to say item key mode plus a certain value. Since it's item 3 is a left arrow and key mode's going to be 1, we need to say item key mode plus 2. Then we can do the same thing for the up arrow, but here instead we say item key mode plus 4. Now this should work. As you can see, key mode's 1 and I can move fine with the arrow keys. In fact, you might not know what keys I'm pressing, so I'm just going to be recording on my phone. As you can see here, I'm recording on my phone. And then I'm going to move left and right, and it's working. I can jump with the up arrow key as well. However, the moment I set this to 2, these keys will no longer work. And then if I move to my WASD, then they work. They jump up and down like that, and that works pretty well now. Now, the next few parts of this tutorial are not really platformer related, but they're more efficiency and game loop related. So look at all of this code just in our when go click stack, right? all of this is super inefficient, especially considering that all we do here is just set variables and do the game loop stuff. So what we can do is what we did with this movement platformer script and split this piece of code into two parts. This one could be called reset. So reset, and we can pass in an input of x and y, pass in two inputs of x and y, so we can basically govern where the player starts. Now we can put in a go to xy block, and then we can say x and y inputs go right there. So where we put the arguments, now we can put like where we want the player to go, and that looks pretty neat. Let's try -55 and -98. Now for this one, we have to make another custom block, and we're going to be calling this one game loop movement player, because this is going to govern the entire movement of the player. Be sure you do not run this without screen refresh, because it is a long running script, and it'll all get messed up if we try to run it all in one go. Now we need to put this in a forever loop, and that should work about now. And as you can see, it's working perfectly. The code's a lot more organized, and we haven't messed up anything yet. Always a good thing. Now, something else I want you to notice is that this when go click stack is also super inefficient, because while we're doing this, we're ceding control to all Scratch. If we want to access this piece of code again, we can't, because it's automatic on when go clicked. What we can do is make a new broadcast to counter this problem, and we're going to call this broadcast init reset, or initial reset. And this might seem pointless at first, right? Why make a whole new separate broadcast for just one custom block, one line of code? And as we develop this platformer later on, there might be more stuff we need to put under this hat block, under this broadcast. So it's just nice to organize stuff like that. Same thing could be said for this. We might have multiple game loops, and so if we say broadcast ultimate game loop event, ultimate game loops, and then here we're just going to broadcast the ultimate game loops script. We're just going to broadcast the ultimate game loop script. This automatically makes our code so much more efficient. And why is it so small? There we go. I'm just going to move it to this side, and that's basically all the organization done. And as you can see, nothing really changed that much, but it's going to really help us a lot when we make our platformers much bigger and in need of better graphics in the future. And one thing that I actually left out in the platform tutorial was slope detection, and a lot of you might also be asking in the comments, where's that wall jumping that you showed us in the previous tutorial? I decided not to include it because, well, let's just be real here. Wall jumping is really only a feature of those boring generic platformers on Scratch, and they've kind of lost their interest. They're just not fun anymore. Like, wall jumping is good when it's done right, and it's not really a mechanic when you think of platformers. But slope detection, walking on slopes, is of course a full-on platformer mechanic. So how do we fix that? Well, in the other tutorial, I said how you could repeat however long the xval was and change the y by a certain value. Like, change the y by a finite value like 8 or 16, so that you could determine on how steep your slopes can be. However, that's a really short-sighted way of thinking, because if you had say what's a good value? A 65-degree slope, and you only did a repeat 8, that wouldn't exactly work, because 65 degrees is really high according to Scratch term. It's like this high. So a way we can limit our slopes to less than 90 degrees, but also allow for all slopes between that is well, I'm just going to show you right now. So we removed this temporarily because this is the wall collision code, and then we're going to say change y by 1, so that we try going up to see if we're touching a wall, a level. And then if it's touching the level again, even after this initial check, then we say, oh, I'm just going to be a little more lenient. I'm going to go up again. This is different from the other tutorial, because instead of it being linear, it's checking on an exponential curve. So when it does the second check, it's already checking like 20 or 30 degrees above what it was currently. And then finally, if it's here, if it failed both tests, if it's still touching the level, then it's a 90-degree incline, and we just stop. this should work for the time being. It's good enough, right? It's good enough. It doesn't break. Pretty cool. Now we can actually change this even more because this is also a pretty long snippet of code. We can change this by making a new custom block, calling it slope detection. Slope or wall detection, and then running without screen refresh, putting that right there, and then finally we put the slope and our wall detection in there. You know what? I think that might be a bit too organized. I'll just leave it like that for now. That is pretty cool. So that's pretty much it for all of the code and organization for the platform and mechanics and game loops that we're going to be doing. And we have achieved a lot. Starting from a blank slate is often, it can be challenging at times. But imagine if I initially started with the script from the first part one, right? I think that was like one custom block, and like it was a weird system with an algorithm to check for Y collision and X collision, and we repeated the ceiling of the absolute value of xvel plus 1. So that would have been a bit hard to explain how to adapt. Starting from a blank slate is it just feels refreshing to look at it from a new perspective. So before I end the video, I just want to recap all of the essentials that we learned from the video. So the first thing that we learned about is first you have to make a stable platformer script by creating one custom block and saying first we created the key controls, right? If the up arrow is pressed, then set yvel to 14 or 15, and if the right and left arrow key is pressed, just change the x velocity by that value, add friction, and affect the movement. And then we decided to add collision. So adding collision, we did all in one custom block, and we said if touching level, repeat until it's not touching level, go one increment until they're out. And then for the X collision, we basically did the same thing. And then we split the movement and the collision into their own custom blocks. And then we split the Y and the X collision into their own if statements. And we did that same for the Y movement. We said X movement and Y movement. And then we decided to split off the slope and wall detection in its own script. What we did after that was, I can't remember. Oh yeah, what we did after that was we created a list for the key controls, and we created a key mode variable so that now we don't have to do right arrow, left arrow, and up arrow. We could do WASD, and we could do that with the simple flick of a switch, quite literally. And then what we did next was we automated as many hard-coded values as possible. And actually, I'm gonna automate one more value. I'm gonna call it jump force. Actually, I'm gonna automate two more values: jump force and jump tolerance. Jump tolerance is like this 5 value that prevents us from jumping too high into the air, but also gives us a little bit of lenience. So we're gonna put the jump tolerance in there and put the jump force in there. And then I'm just going to set jump force and jump tolerance to 15 and 5. Now that should work. Alright. And then the next thing that we did after the key controls and key mode was we learned how to order game loops and broadcast messages. This is to clean up code in the future. We learned that when green flag clicked doesn't allow too much control on scripts. And we also moved all the game loop, all the movement code, player movement code, into their own custom block. And that's pretty much it for this tutorial. Okay, so now let's compare the finished product of this tutorial with the original platformer script in part 1. First, let's start off with the movement, right? Movement is pretty much good. Here we have nice ceiling collisions, floor collisions, wall collisions, and movement's pretty good. It's a bit janky, and because some of the values are hard-coded, not really that much editability. Then with our new code, we have nice movement. We can jump. Ceiling collisions work like a treat. We can alter our inputs. We can change the friction, move speed, all that if we wanted to. And we can even change the keybinds, so we can use the WASD keys with a simple flick of a switch, quite literally. Now let's move on to some more complicated aspects, the slope detection and the wall detection. For this project, it will detect walls, but you can also jump. You can wall jump on walls, which I removed in this version. And the way you wall jump too, it's more like you're climbing on the walls. And going up slopes is pretty much unchanged. It is a bit janky when you go back down. Let's see in this project. As you can see, wall jumping is it's totally been removed. And would you look at that? Going up slopes feels so much more realistic. Whereas in the other version, they're a bit fast and almost like you were sliding on ice or something with very low friction. Here, it feels like you're actually going up an incline, and it takes some effort because you go a lot slower when you're on an incline, a slope. So that's that. Now let's take a look at the code for part 1 versus this part 2. Alright, so let's take a look at this. As you can see, already we're in like 3 custom blocks: restart, platform physics, and the game loop, which has very little control. We as a programmer have very little control over the game loop, but here we have all the control over the game loop because we can control when we reset or start the game loop. And here it's not all in one script. It's all like split into different functions depending on who's doing what. And in the other tutorial, I used a justification of all the mechanics were broken down into their own custom block. In this tutorial, we're going to combine all those mechanics. This tutorial is not like for this project. It's not the mechanics that are split into custom blocks, but rather it's the overall functions of the player. So like there's not a separate custom block for up arrow movement, right movement. As you can see, I did do a solution for that. I made an input, a kind of toggle input, but I only made them be one function in total. And then here, the slope and wall detection, use that code where it changes Y, and if it fails that test, changes Y again. If it fails, treat it as a wall. And yeah, that's pretty much it. Also, the game loops are a lot more in my control. And for this platform physics script, you can see it's long. The wall jumping script really, you can see that I do have some non-hard-coded values, but they're all like inputs, as you can see, which means that you really can't edit them the same way you do with variables. And you can see this algorithm over here, this one over here. You can see another algorithm for the slope detection. And old Y is just kind of like a way of storing the old Y position before you restore it. But obviously we know that here it's kind of renders it unnecessary if we do it with this method. But yeah, those are the differences with the code. And the overall takeaway from this tutorial is that while it's always better to not have your code all cluttered, it's also not good to just have all your code in one stack like this. So yeah, you have to clean up your code, but clean it up efficiently. That's kind of the main takeaway from this. Alright, that's it for this tutorial. If you really enjoyed, then smash like and smash subscribe. Once again, thank you for 208 subs. And yeah, the next tutorial is coming, I think, next year. So I'll see you later. Bye, Sans Coders.